Nidavellir is real? Seriously? I mean, that place is a legend. They make the most powerful, horrific weapons to ever torment the universe. I would very much like to go there, please.
Well, how about I once again explain in great detail why travelling to a neutron star is a really stupid idea and will result in an unfathomably painful death. Hello there and welcome to No Useless Questions, where today we're going back to Nidavellir, this time to look at what it actually is, how it could be constructed, and as always deciding whether it makes any sense. Hopefully this time I don't get distracted by one throwaway line from Odin that still makes literally zero sense at all. So as we discussed in part 1, the MCU's Nidavellir consisted of a spherical megastructure surrounding a neutron star, with a series of enormous rings at a larger distance from the star housing the dwarves and their weapons forges. The way it's portrayed in Infinity War makes it seem as though the sphere is used to harness and focus the energy from the star into the forges. That type of structure is actually a theoretical construction called a Dyson sphere, which is an indicator for a Type 2 civilization on the Kardashev scale. Right, now that I've put all the scientific sounding word vomit out there, I suppose it's time for me to actually explain what all of that nonsense meant. First, we'll look at the Kardashev scale. In 1964, Russian physicist Nikolai Kardashev proposed a method of measuring the technological scale of a civilization's development. He suggested there were three types of civilizations. Type 1, or planetary civilizations, can harness all the energy from their planet, which is a power of magnitude 10 to the 16 watts. A Type 2 civilization, or a stellar civilization, can harness all the energy from their solar system, which is about 10 to 26 watts of power. A Type 3 civilization, or a galactic civilization, could harness all the energy from their galaxy, which is a power of 10 to the 36 watts. Kardashev himself only deemed these three types to be possible, however the scale has since been extended to include Types 4 and 5, or Type Omega for some reason, which are universal and multi-universal civilizations, where Type 4 can harness the energy of their entire universe, and Type 5 could harness the energy of multiple universes, and theoretically could then use that energy to create more universes. This is where we're going to very, very theoretical ideas. Carl Sagan devised an interpolation system that would include decimal types, which in 1973 put humans at Type 0.7, and by 2018 we had developed a Type 0.73 civilization. It's been theorised that we're about 100 or 200 years away from being Type 1, meaning that we could harness all of the Earth's energy. Going back to the Type 2 civilizations, to capture all the energy from a star, they would need a megastructure like a Dyson sphere or Dyson swarm, as theorised by Freeman Dyson in 1960. A Dyson sphere is a giant structure surrounding a star, collecting all of the energy it outputs, with a Dyson swarm being a series of structures surrounding the star. And I've said Dyson way too many times already. The structure would collect the energy from the star and transport it to wherever the civilization is based. To put how much energy this is into perspective, the sun outputs enough energy each second to match the Earth's current energy usage for over 650,000 years. So if Dyson spheres can collect so much energy, why haven't we made one yet? If you're actually asking that question, then you really don't understand how big the sun is. If you created a swarm using 1 square kilometre satellites, it would take 30 quadrillion of them to surround the sun. To get the materials to create a large enough structure to surround a main sequence star, you need to pretty much disassemble an entire planet. To do this, you'd need near enough the energy captured by a Dyson sphere. So to build the Dyson sphere, you'd need a Dyson sphere. You're seeing the problem here now. Despite all of this, it's deemed possible that Dyson spheres not only could exist, but possibly already do somewhere in the universe. None have yet been found, but if there are any out there, then we'd be able to see them by a star being dimmed as the structure moves around it. Back to Nidavellir now. First, is that supposed to be a Dyson sphere? Easy one to answer, yes it is. But is it a realistic one? Well, as realistic as a theoretical superstructure in outer space that we've never actually seen can be. So when we consider how realistic it can be, we look at how Dyson spheres are theorised. Normally they are considered with main sequence stars, whereas at Nidavellir it's obviously, as we've discussed, it's a neutron star. When looking at the size of the sphere, it looks very small compared to the size of the star. With a main sequence star, the sphere could be up to 2 astronomical units away from the star, though that is a very big Dyson sphere to be creating. whereas with Nidavellir it looks like the sphere is almost the same size as the star. As we discussed, for the creation of the sphere we'd probably need a planet to disassemble to get the matter, and that planet would need to be habitable realistically, so that they could set up an outpost there to be able to extract the materials needed for creating the sphere, and then using it as a hub to create the sphere itself and send it out into space. The sphere would also need to be created post-supernova, because especially with how small the Dyson sphere is in Infinity War, that sphere's getting destroyed by a supernova if you try to build it around the star before it goes supernova. And even then, with how small it is, that would be well inside the supernova, and it would be well inside the star as it was before it collapsed, so obviously it was built post-supernova. Going back to the need for a planet to be around the star, research from the University of Cambridge in 2017 found evidence of exoplanets around pulsars, though whether these planets formed before or after the supernova is unknown. For these planets to be habitable, they would need to be up to 10 times larger than Earth, with an atmosphere that's 1 million times thicker, and the environment on this planet would resemble deep sea conditions. The temperature on the planet would need to be right for liquid water, and the distance from the star needed for that temperature would be dependent on the luminosity of the star, as shown by the graph that I've hopefully put on screen in editing that came from that 2017 study from Cambridge. Now, despite all of this making sense up to this point, creating something that close to a neutron star would be impossible for multiple reasons. First of all, as we said in part 1, the gravitational forces near a neutron star are mind-bogglingly huge. So any structure that you make there is getting instantly destroyed by gravity. Second of all, the magnetic forces near a neutron star are huge. We didn't discuss this so much in part 1 because I thought, atomizing and vaporizing enough was scary. Just to give the magnetic forces a sense of scale, the magnetic flux density on the surface of the Earth is about 0.6 Gauss. The flux density from the Sun is about 1 Gauss, but the magnetic flux density from a neutron star can be up to 1 trillion Gauss. Finally, as we did say in part 1, the temperature on the surface of a neutron star is around 600,000 Kelvin. So if you're making a structure there, you need a material that can withstand temperatures that high. Well, tungsten has a melting point of 3,695 Kelvin, and that's the highest we have in real life. But then there's Uru, the metal that is used to create Mjolnir and Stormbreaker. That melts at 50,000 Kelvin. So whatever they use to make the Dyson sphere has to have a higher melting point than the material used to make these super powerful weapons. If that's the case, if this material is that brilliant, why is that not being made for the weapons rather than Uru? Overall, there is technically a possibility of constructing a Dyson sphere around a neutron star. However, the one in Infinity War would not work at all without some magic material that can withstand the forces and temperature of a neutron star, and that material would be stronger than Uru. So if you really wanted to build a Dyson sphere around a neutron star, you need to build it much further away, likely nearer to the habitable zone of that star, to avoid the whole thing being crushed and vaporized in the same way we said, Thor, Rocket and Groot would have been in Infinity War. So now comes the point where I try to balance science with actually making a compelling story. First of all, I do have to say I am impressed by the inclusion of a Dyson sphere in all of this. I've shown it on screen that it was actually intended to be a Dyson sphere, but just the fact that they would use that idea on its own is enough for me. Like, people, when they look into this, will learn about Dyson spheres and may even get onto the Kardashev scale, even if it is somehow just through this video. That is bringing some scientific ideas into the mainstream, which I'm always going to applaud. And there is no doubting Nidavellir is incredibly visually impressive. Like, when I looked into a bit of it from the visual design stuff, my word, that is incredible stuff. Now for me to move away from praising the film to get back to the me ranting about stuff thing. This didn't really fit anywhere else in these two parts, but the bit when they talk about how the star has gone out.
Something's wrong. The star's gone out.
That makes no sense. Stars don't go out. You can't turn off a star. That's not how it works, Thor. What happened is that whatever they have functioning in the Dyson sphere, that had obviously stopped working, and with the rings that stopped working. The star hadn't gone out. That's not how stars work. And I think I've made my point in this, that they could have made the Dyson sphere more accurate. They could have made all of this more accurate scientifically. You know, but then again, it wouldn't have looked so visually impressive. You can't really show something that is millions and millions of miles across on screen and still also have characters being, you know, visible. So, yeah, I get why it's not completely scientifically accurate, and I'm not going to say, oh, they should have made it much better, they should have made the whole thing bigger. No, that wouldn't have worked, and I know it doesn't work. And I know I'm stretching it a bit here though, but I would have liked a bit more discussion of the neutron star. It's just the science nerd in me wanting more, but I know that's not really what the point of Infinity War is. It's not a science lesson. But, you know, some indication of the forces from a neutron star could have been shown, but writing it all off with magic is always the easy solution. So hopefully you've learned a thing or two, or most importantly, hopefully you've been entertained by me rambling at times. I feel like I've done a good job of keeping the rambling down this time. As always, I'll be linking to resources with more information about the individual topics that I've talked about in this. If you've enjoyed the video, make sure to subscribe for more like this. And any questions you have, put them in the comments below, because as I always say, there are no useless questions here.